Hello students, in this module we are going to see some entrance problems based on integration by paths. Let's take the very first example. It is evaluate the integral log of x the whole raised to 4 dx. Now my dear students, which of the four options is the correct answer? Let me just start by mentioning a very simple point here. Log of x the whole raised to 4, can I say it's a composite function? Correct? So if I have a composite function, it can be easily solved by substitution. So let us go for the substitution. Now if I have log x is equal to t, what is the next step? X is equal to e raised to t. Time and again I have been reminding you that it's a very important relation. If I put log x is t, the exponential form x is equal to e raised to t is very, very important. So let's write log x is t, but if I differentiate this equation, I'll have to find the value of x in terms of t, which I will do before differentiation. So we will get x is equal to e raised to t. Now if I differentiate, dx will become equal to e raised to t dt. We have the value of dx, we have the value of log x. So now we can exclusively write the integral in terms of t. So let's write that. Integral will become, since log x is t, can I say integral will become t raised to 4 into dx is e raised to t dt. So that is e raised to t dt. Now this particular integral is of the form e raised to x into x raised to 4, which I did into a shortcut. Now let's recall that shortcut for our reference. Now my dear students, this is the shortcut which can give me a integral of e raised to x into a polynomial of x. Now what should we observe? Should I apply the shortcut? Not necessarily. My dear students, even if you observe some small points from the shortcut, you will get the answer very easily. Now if you observe and if you recall the alternate plus and minus in the formula, if you observe this, you have the answer. There is only one option which is following the alternate plus minus pattern. Options A, B and C violate this pattern. They do not have alternate plus minus sign. There is no term in the integral which can change that. So options A, B, C cannot be the answer. So it is but obvious option D is the correct answer. Also my dear students, if you want to write the formula or if you want to evaluate the integral, the answer will be e raised to t into bracket t raised to 4, then derivative of t raised to 4, which is 4t cube, its derivative 12t square, its derivative 24t and its derivative 24. Further derivatives become 0. Put an alternate plus minus, then put a plus c. That's your answer. Resubstitute log x in place of t and in place of e raised to t put x. Okay? Very simple sum. Let's take one more. Integral of sine inverse 3x minus 4x cube dx is equal to which of the four options? One of them being none of these. Whenever you have none of these, it is advisable to solve entirely. Don't go and mark the answer halfway. It may not be completely as given in the options. Now my dear students, if I recall 11th standard, sine of 3x minus 4x cube. Now when I think of 3x minus 4x cube, I can understand this function can be converted into sine 3 theta. If I substitute x is equal to sine theta. So let us put x is equal to sine theta. If I put x is equal to sine theta, we can say theta will be sine inverse of x. This I will require later. Now my dear students, so sine inverse of 3x minus 4x cube will look like what? It will become sine inverse of 3 sine theta minus 4 sine cube theta, which is nothing but sine inverse of sine 3 theta. Now sine inverse of sine 3 theta will become nothing as 3 theta. That is 3 times sine inverse x. So the function inside the integral on simplification gives me 3 times sine inverse x. You can very well understand option A and B possibly can be the answer. Now 3 times sine inverse x, if I have to integrate, let me take the 3 outside. Sine inverse is alone. Whenever inverse function is alone, the second function can be taken as 1. So we'll write in the next step u into v rule, where u will be sine inverse x and v will be 1. We will get sine inverse x integral 1 dx minus d by dx of sine inverse x integral 1 dx the whole dx, and that is what we need to evaluate. Now integral of 1 is nothing but x, so the starting term will be sine inverse x into x, that is x sine inverse x, minus derivative of sine inverse x is 1 upon root over 1 minus x square, and integral 1 is nothing but x. Now my dear students, we are left with one small integral to be evaluated. We do observe that difference in the degrees of x in the numerator and denominator is 1. So we can adjust by derivative. Let us check that. So x sin inverse x remains as it is. Now let me write the integral. What we need to do is adjust the derivative of 1 minus x square in the numerator. Now derivative of 1 minus x square is minus 2x, out of which x is already there with us. So what we require is a minus 2, and since we require a minus 2 inside the integral, outside the integral we'll have a plus 1 by 2, because that minus is transferred inside. Now my dear students, when I write this, in the next step we'll understand what is the answer. So 3 times x into sine inverse x plus half. Now my dear students, the integral which we have is of the form f dash x upon root f of x, and we have already seen this in integration by substitution, and that particular integral on simplification will give me 2 times root of f of x, that is 2 times root of 1 minus x square. Now my dear students, what we need to do is just cancel out the term there, and we get 3x sine inverse x plus root of 1 minus x square, which is nothing but option B. So your correct answer is option B. That's all we have in this module. Thank you very much.